It's not Thursday in class, or Tuesday in class, sorry. Over here, let's go to 18. Piece of cake now, baby. Adding radicals together. You treat a radical like it's a variable. My friends, 2x plus 3y. Can you add those together, 2x and 3y? Not like terms. But what if I add 2x plus 3x? Can you add those together? That's 5x. So if you had, say, 2 square roots of 2 plus 3 square roots of 5, and you're treating radicals like they're variables, can you add those together? Can you add radical 2's and radical 5's together? No, you can't. But what if I said 2 square roots of 2 plus 3 square roots of 2? Aren't these both square roots of 2's? If you had 3 square roots of 2 and 2 more square roots of 2, you have a total of 5 square roots of 2, correct? So all we got to do is simplify these radicals and see if we have any nice, neat guys. I believe we'll just do it like this. Biggest perfect square that goes into 50 is how much? 25. How many times? 2 times. Plus 4. Then we got to split that 500 up. Biggest perfect square that goes into 500 is 100. How many times does 100 go into that? And minus 6. Sorry. Come on, pen. Minus 6 times 2 radicals. Biggest perfect square that goes into 125 is 25. How many times? Cool. Now I'll do a little bit of double cleanup. I know that the square root of 25 is 5. Take it times 2 more, and then you get 10 square roots of 2. Plus square root of 100 is 10. Take it times that 4, and you get 40 square roots of 5 minus 30 square roots of 5. Y'all cool with where the 30 came from? Do you have any quote-unquote like terms in this bad boy? You got some radical 5s. 40 radical 5s, take away 3 radical 5s is how many radical 5s? Yep, 10 radical 5s, but that 10 radical 2 at the front didn't get to go away. It doesn't matter that those coefficient type guys are the same. It's all about the radicals. Radical 2's and radical 5's are different things. Just like 10x plus 10y, you don't get to add those together and say that that's 20 or anything like that. It's 10 square roots of 2 and 10 square roots of 5. Let's jump over to 19 and call that our last one of these today. Simplify all of those radicals on 19. So, you can watch me. All of them are radical 5s. You must use the order of operations and work from left to right, though, when you do your adding and subtracting. So you have 2 square roots of 5 plus 5 square roots of 5, which is really 7 square roots of 5. Take away 3 square roots of 5, and don't you have 4 square roots of 5 in that situation? Do you understand what we're doing on these problems? Piece of cake. Let's go to something like 22 right here. You see we're going to take radicals times radicals. You can do that. I highly advise, if you see some radicals that can simplify first, to simplify them first, especially since it's non-calculator type stuff. So see this square root of 60? Simplify him. Find me a perfect square that goes into 60 evenly. And it's 4. How many times? Take a wild guess how many times it'll go in there. 15 times. Right? So I just wrote him above it a little bit, and don't I really have 2 square roots of 15 right there? Isn't that what that is? Square root of 4 times square root of 15, 2 square roots of 15, and plus 1 more square root of 15. Can we add those together in what's inside the parentheses? Square root of 15 plus 2 square roots of 15 is how much? 3 square roots of 15. Cool? So I simplified it as much as I could. Now, numbers times numbers is how you roll. 2 times 3 is? Radical 3 times radical 15 is radical 45. Then, of course, we go so far, and we got to see, can the square root of 45 simplify at all? Perfect square that goes into 45. 9. So that becomes 18 square roots of 5. If you wanted to separate it, I told you you can skip some steps in simplifying square roots. I do not advise doing that for cube roots or fourth roots or anything like that. Separate them out, okay? But square roots, if you want to skip some steps. Number 23, just give you some advice. Look what happens if we multiply them together first. What kind of root do we have? Square root. If you took that 8 times the 2, what would you get? A perfect square. If you took c to the third times c to the first, you would get c to the fourth, which is a perfect square. And you take d to the fifth times d to the third, you'd get d to the eighth, which is a perfect square. So let's multiply these together. You got to take the 6 times the 4 times each other also and get the 24. And then you'd get radical 16 c to the fourth d to the eighth, right? You just multiply all that stuff together, and lucky us that whole square root is nothing but a perfect square, just like your homework quiz today, piece of cake. It becomes 24 times 4c squared d to the fourth. And of course, we just got to multiply 24 times 4. We got to do it without a calculator. And if you need to jump off to the side, you do that. You know, if you got to jump off to the side, do it. And it's 56 c squared d to the fourth. Why don't you try 24 on your own? Watch your index, multiply everything together. Should get 6 fourth roots of 16 x to the eighth y to the fourth, right? When you multiply, I'm not done. I just multiplied them together is what I did, right? Look at everything underneath there. 16, is he a fourth? And all of these, 8's a multiple of 4, 4's a multiple of 4, aren't those all perfect fourths also? Lucky us. 6 times, just be careful with that 16. He's Mr. Optical Illusion, him and 64, right? There are all these different kinds of perfects. What's the fourth root? 16. 2 x squared y. And then you multiply them together and get 12 x squared y. Hang in there. Only got a couple more. It's not in difficult land anymore. 25. I would not want to multiply those two cube roots together without a calculator. I don't want to take 81 times 24, even though I could write it out. I don't want to do that. Why don't we try to simplify each one of them separately first and get some smaller numbers out of that? So 81. Is 81 a perfect cube? So we need to check it out. 1, 8, 27. Sure that 81 is not a perfect cube? 4 cubed is 64, right? And yeah, so 125. Let's work backwards. 125 is too big. Does 27 go into 81 evenly? Isn't 81 like to the fourth power, right? Isn't it 3 to the fourth, right? So wouldn't this be really 27 goes in there? How many times? 3. All I'm doing is splitting up Mr. Left guy. That's cube root of 81. How about 24? What's the biggest perfect cube that goes into him? 8. How many times? 3. So see if you can clean that up. You got a couple of perfect guys and a couple of non-perfect guys. Really have this. With me on the 3 cube roots of 3 times 2 cube roots of 3? Yeah? And then 3 times 2 is 6. Is the cube root of 3 times the cube root of 3 3? The square root of 3 times the square root of 3 is 3, correct? But what's the cube root of 3 times the cube root of 3? Check this out. What's the square root of 2 times the square root of 3? What's that turn out to be? Square root of 6. What's the cube root of 3 times the cube root of 3? It's not 9. It's the cube root of 9. Is 9 a perfect cube? No. And that's it. We'd be done with that. Oh, God. 26. Just a few more. Hang with me. What do you have to do number 26 correctly? What are we taking times each other? A what times a what? Binomial times a binomial. What's the process called? FOIL. First terms times each other. 2 times 4 is 8. Outside terms times each other. 2 times the square root of 7 is 2 square roots of 7. Inside guys times each other. 3 square roots of 7 times 4 is 12 square roots of 7. And then here's where we need to slow down a little bit. Do you see when we take the last times each other, you got the same radical in there. You got radical 7 and a radical 7. What's radical 7 times radical 7? But there's also a 3 in there, right? You need 3 times 7, which is how much? 21. 3 square roots of 7 times the square root of 7 is 3 times 7, basically, correct? Which is 21. Like terms, 8 and 21 are like terms. That's 29. And aren't the middle terms like terms also? 2 square roots of 7 plus 12 square roots of 7 is 14 square roots of 7. Nice? Let's FOIL the old number 27. First terms times each other. 6 square roots of 3 times 3 square roots of 3. Well, 6 times 3 is 18, right? And square root of 3 times square root of 3 is 3. So you got 18 times 3. You got to go off to the side and figure that out. Go off to the side and figure it out. 18 times 3 is what we really have here. I got you. Just letting people change. We should get 54. Just making sure you get it. Outside guys times each other. Wouldn't that be 6 square roots of 6? Right? So 6 times the 1 is 6. The radical 3 times the radical 2 is radical 6. Inside guys times each other. (12 square roots of 6). Last terms times each other. See if you can get that without my assistance. Last terms times each other. And I would be willing to bet that there's an involved in your answer. But is it positive or negative? Watch that sign. We get so lost of the 4 radical 2 times 2. Radical 2 is 8. You know that we didn't see that it was a negative 4 square roots of 2 times radical 2. The radical 2 times the radical 2 is 2. Take that times the 4 again, you get the 8. Like terms, we've got 48 plus minus 6 square roots of 6. Yes, sir, Rebob? And now, what I've noticed, our nemesis. Yes, sir. Thank you. 46. My bad. We have done a poor job of recognizing conjugates and multiplying conjugates together. There is a shortcut to multiplying conjugates together. You don't do the whole FOIL process. What part of the FOIL process do you do when you multiply conjugates together? First and last. First and last. So let's do number 29. Okay, let's skip over 28. We get him. 29. Do you see that this is bad because there's a radical in the denominator? But there is not just a monomial in the denominator. It is a binomial in the denominator. To get rid of the radical, we will need to multiply by the conjugate of whatever that is right there, since it's more than one term. We messed that up earlier. We would still put radical 5 minus 1. What is the conjugate of radical 5 minus 1? Radical 5 plus 1 over itself. And I know you don't like this stuff, but it's not nearly as bad as you think it's going to be because they're conjugates, and it's going to come out real nice. That's the whole point. The point of doing this is we're going to make the radicals go away. That's why we're multiplying by the conjugate of this. So numerator gets a little distributive property. 2 square roots of 5 plus 2. The denominators are conjugates. You only take the first terms times each other. And what's radical 5 times radical 5? It's 5. And the last terms times each other. Negative 1 times positive 1 is a negative 1. And by God, there are no more radicals in the denominator when we did that. Right? It's just 5 minus 1. And what's 5 minus 1? So you really got 2 square roots of 5 plus 2 all over 4. And I'm separating that out now. Right? Instead of the all over 4, I just put each one of them over 4. Can that reduce at all? Yeah. So square root of 5 over 2 plus 1 over 2. Not like terms, because one of them has a radical with them. The other one does not have a radical with it. That's why you can't add those together any further than that. How about the next one? Let's jump to 31. Do you have more than... Well, let's not jump to 31. Let's go to 30. Do you have a radical in the denominator? Yes. How many terms are in that denominator? Just one. All you'd have to multiply by is radical 3 over radical 3 to get it simplified. Right? Yes, sir? Yes, you could. You could split it apart and divide it all out, because radical 48 over radical 3 turns out to be radical 16 over radical 1. Radical 75 over radical 3 becomes radical 25. So here's what he's saying. The simple way, split it up. If you wanted to do that, you could. And since you have a radical over a radical, you really have those cancel out, the 5s. You got the square root of 16 over the square root of 1 plus the square root of 25 over 5 in this situation. This is 4 plus 5 over 5, which is really 4 plus 1, which is really just 5, is what that really is. Don't worry. My point was, monomial or binomial in that situation, what do you have when you have these problems on your homework? What do you have in the denominator? Monomial or binomial? What is this? Monomial. You don't do the conjugate situation. Over here, what do you have in the denominator with a radical? Monomial or binomial? You must multiply by the conjugate of the denominator. So let's do that. What's the conjugate of the denominator? 2 plus the square root of 2. Yeah. The top guy now, those are not conjugates or anything like that. So we got to FOIL them out. Get into a bigger window here. Yeah. 8 plus 4 square roots of 2 plus 2 square roots of 2 plus 2 all over. The bottom is conjugates. Supposed to be easy. Supposed to be easy. Supposed to be easy. 4 minus 2. First terms times each other is 4. Last terms times each other will always turn out to be negative, because you're taking a positive times a negative. That's why they're conjugates. And then you got 10 plus 6 square roots of 2 over 2, which is 5 plus 3 square roots of 2. Yes, sir, Bob?